today we're going to look at three-dimensional objects. So the first one that we have is a prism. So a prism is a 3D figure that has the same cross-section all along its length. Okay, so I'm just going to look at a revision of cones, cylinders and spheres. Okay, so this is what cylinder is. Here I have my radius and my height. So the volume of a cylinder is pi r squared h. Okay, and these formulas are found in our log tables, and the surface area is this. So in your log tables, all it gives you is the formula for the curved surface area, so basically the outside of it. So I'd have 2 pi r h, and then because I have two circles on top and on bottom of a cylinder, so it's 2 multiplied by pi r squared, the area of a circle. And this is what the net of a cylinder looks like. So a cone, the volume of a cone is 1 over 3 pi r squared h, and the surface area, similar to last time, is going to be pi r squared because we have a circle at the bottom, and in our log tables it only ever gives us curved surface area, so it's pi r l. Okay, so in a cone here, this here is my perpendicular height. Okay, so that's my h. The word perpendicular, we always think of the word right angle. Okay, so it makes a right angle. L here is my slant height. Okay, so L stands for my slant height, and then R is my radius. Here I have a sphere. Okay, so the volume of a sphere is 4 over 3 pi r cubed. Okay, if I was asked to get the volume of a hemisphere, so half a sphere, okay, that's equal to 2 over 3 pi r cubed. The surface area is 4 pi r squared, and the surface area of a hemisphere is 3 pi r squared. So a few moments ago I gave you the definition of what a sphere or what a prism was. Okay, and to get the volume of my prism, okay, it's equal to the area multiplied by the length. Okay, so we were talking about the area of the cross section there a few minutes ago, and that the length is all the way the same. Okay, so this is my area of my cross section, okay, and this here is going to be my length. Okay, so the surface area then of a prism is 2 times the area. Okay, so area of my triangle, so 2 of my areas by my triangle plus my length multiplied by a plus b plus c. Okay, so a plus b plus c. Okay, so generally speaking, the volume of a prism is equal to the area of the base multiplied by the length. Okay, now we're looking at different things like percentage error, tolerance, degrees of accuracy. So during an experiment, John estimated the volume of a liquid to be 100 millilitres. He then measured it and found to have a volume of 125 millilitres. Okay, so I'm getting the percentage error. So the first thing I need to do is I need to actually figure out what is my error, and it's always over your actual value. Okay, so my error in this case is going to be 125, take away my 100. So it's 25 millilitres. My actual value in this specific case is 125, so it's going to be 25 over 125 multiplied by 100 to find out what is my percentage error, and I get the value is 20%. Then here I have something similar, so it's tolerance. So if a measurement is taken against a scale, so example, a ruler measuring length in millimetres, a balance measuring mass, so weight in grams, a clock measuring time in seconds. Okay, so the accuracy of the measurements is limited by the size of the smallest unit on the scale. So the tolerance of that measurement is always plus or minus a half the base unit of the scale. So we say that the measurement is taken to within plus or minus 0.5 of the basic unit. So here I have like millimeters on a ruler. Okay, so this here reading is 24, but it could be plus or minus 0.5 as well. I have to take in my tolerance as well, and this here is 27.5, but it's also plus or minus 0.5. So you've taken your tolerance above and below your value. So here I have an example. So it says, find the volume of the geometric cones shown at Friston correct to 1 decimal place. Okay, so it's drawn out here. I will attach the PowerPoint with the drawings to help them be a little bit clearer. Okay, so basically this here is 4 centimeters. This here, the circle on the bottom is 6 centimeters. So it's a cone. Basically, it's a cone with the top of it cut off. So what I want to do is from similar triangles. Okay, so this one way of doing it, I've done it out 2 separate ways because there's a formula in the log tables which might help some of us. Okay, so from similar triangles we have basically, right, so we know that from here to here that's 8 centimeters. Okay, and we know that I just said there a few minutes ago that it is a cone. It should be a cone, but the top of it's cut off. Okay, so there's a little bit extra here. Here is 4 centimeters. This is obviously going to be 8 centimeters again. Right, this from A to D. Okay, so this here, the full way across, is going to be 6 centimeters, and then my full height of my cone, I don't know what it is, so I'm just going to call it H. Okay, so basically I have H take away my 8 over 4 is equal to my H over my 6. So then I cross multiply, so I get 6 bracket H minus 8 is equal to 4H. So I get 6H minus 48 is equal to 4H. 2H is equal to 48, so H is equal to 24. So my full height there is going to be 24. Okay, so the volume of the larger cone is 1 over 3 pi r squared h. Okay, so it's equal to 1 over 3 pi, my radius is 6 squared by my height, which we just found out is 24, and that's equal to 288 pi. The height of the smaller cone then is going to be h take away 8 is equal to 16. Okay, right, so it's 1 over 3 pi r squared h is equal to 1 over 3 pi, my radius is 4 squared, 16, okay, so that's my height that we just found out, and that's equal to 256 over 3 pi. So the volume of my frozen then is my big cone take away my smaller cone, and I get 636.7 centimeters cubed. Okay, there is a formula in my log tables as well that I'll be able to use. So the volume in the log tables, it goes 1 over 3 pi h, capital R for my bigger radius plus r, smaller r for my smaller radius plus r squared. Okay, so I get 1 over 3 pi. My height in this question, h, is 8 centimeters, bracket 6 to be squared plus 6 times 4 plus 4 to be squared. So I multiply 8 pi by 1/3 and I get 8 pi over 3. 6 to be squared is 36. 6 times 4 gives me 24, and 4 to be squared is 16. So I get 8 over 3 pi, and I'm going to add all these up, I get 76. Multiply this together, I get the same answer as what I got previously. So there's two different ways I could have done this sum, and in your diagram in the log tables it does help you to show you which matches up. Okay, so that's why I know that this is my height here, and so on. Here I have another example. Okay, so it says Matt weighed 85 kg before training and 81 kg after training. He took both measurements on a scales measuring in kg. I'm asked to find the minimum and the maximum values for his weight loss. Okay, so the tolerance of his scales is plus or minus 0.5 kg. Right, so therefore I can basically say before training his minimum weight was 84.5 kg and his maximum weight before training was 85.5 kg. After training then, his minimum weight was 80.5 kg, okay, and then his maximum weight after training is 81.5 kg. So therefore I can say that the maximum weight loss was 85.5 take away my min weight here, which is 5 kg, and then I could do the maximum weight loss was also my max weight take away my min over here. Okay, so 81.5, or take away my max as well. Okay, so I got 84.5 kg, take away my 81.5, and I'm left there with the answer 3 kg. So the tolerance interval for his weight loss was 4 plus or minus 1 kg, because we know that it goes between 5 and 3, so it's just going to be 4 plus or minus 1 kg, because 4 plus 1 will give me 5 and 4 take away 1 will give me 3. Here I have another example. So it says a company makes ball bearings, okay, so they're spheres, for a machine with a diameter of 12 millimeters. They claim that they are produced to an accuracy of plus or minus 0.02 millimeters. Find the largest and smallest balls sphering volumes produced. Find the percentage error of the diameter and the volume. Okay, right, so here's my solution. The first thing I have is my diameter is equal to 12 millimeters. Okay, so the max diameter that I could have is 12.02. Okay, because they're built to a tolerance of 0.02, and the minimum then I could have is 12 take away 0.02, and I get 11.98. Okay, so my volume of a sphere is 4 over 3 pi r cubed. So then I'm looking now for my max. Okay, so it's 4 over 3 pi. Right, so I divide this by 2 because this is my max diameter, and I get 6.01 to be cubed, and I get that's equal to 909.310 millimeters cubed. My volume of my minimum then is still 4 over 3 pi. I have my radius of my minimum, and I divide that by 2, and that gives me 5.99 to be cubed, and I get 900.262. Okay, so then the percentage error on the diameter, so my percentage error is my error over the actual value multiplied by 100. So my error is 0.02, my actual value is 12, multiply that by 100, and that gives me plus or minus 0.167%. Okay, then I'm asked for the volume. Okay, so the volume is equal to 4 over 3 pi. My radius is 6 to be cubed, and that's equal to 904.779 millimeters cubed. And then the percentage error of the volume is the error over the actual value multiplied by 100. Okay, so my error that we have is 909 take away 904.779 all over the actual value, which we just found out there 2 minutes ago, multiplied by 100, and I get plus or minus 0.5% as my answer. Okay, so in the next example, we have this model of a skip is used by a recycling company. I'm asked to find the volume of the skip, correct 2 decimal places, and then I'm told, so the company offers a volume pickup at €80 per metre cubed, or a weight pickup at €30 per 100 kg. So assuming a full skip weighs 1.3 tons, which option represents the best value for the money for the customer, and write an expression for the volume of the skip in terms of A, H, W and theta. The final part of this question, it goes, the recycling company wants to redesign the skip with the new angle theta is equal to 45 degrees. If the width, height and overall volume must remain the same in order to fit on the truck, find correct 1 place of decimals, the new dimensions of the top and the bottom of the skip. Okay, right, so the first thing I'm going to do, the first part asks me to get the volume of this particular shape. Okay, so the volume is my area of my trapezium multiplied by my depth, which is 2. Okay, so this isn't a great diagram, but I will send on the questions as well. Okay, so it's the area of trapezium, so it's 2.5 plus 1.6 over 2 multiplied by 1.2 multiplied by my depth, okay, because it is a prism. Okay, so I get that my volume of this particular shape is going to be 4.92 meters cubed. Okay, so earlier on then they were asking me to find out which one is better value for my customer, the volume pickup or the weight pickup. Okay, so the volume we've just worked out is 4.92, and we were told that it's €8 for the volume pickup. Okay, so I did 4.9 by €8, and I get that costs me €393.60. Okay, and then for the weight pickup, okay, so I was told that the maximum that the skip can hold is 1.3 tons, and 1.3 tons is 1,300 kg. Okay, so I did 13 by 100 because we were told the price for every 100 kg is €30. Okay, so there's 13 by 1,000 by 30, and I will get the price that it's going to cost for this one is going to be 390. And I get that because 13 multiplied by 30 gives me 390. So the one that's actually going to be better value for the customer is going to be this one. Okay. The next one then, I was asked to get the volume of my skip in terms of A, H, W and theta. Okay. So we still have a volume of a trapezium. So it's A plus H tan theta over 2 by H by W, and I get A plus A gives me 2A plus H tan theta over 2 by H by W. Now I'm told that theta is equal to 45 degrees, so I get my volume is equal to 2A plus 1.2 tan 45, because we have to use the same, we're told that they remain the same, the values that we had previously, so that it'll fit into the truck. So my height is now back to 1.2 tan 45 over 2 multiplied by 1.2 by 2, and I know that my volume is actually equal to 4.92. We worked that out previously, so I said 4.92 is equal to 2A plus 1.2 over 2 by 2.4, so I get 2A is equal to 2.9 and A is equal to 1.45. So then now I know that my bottom is equal to 1.45 meters, and I say that's equal to 1.5 meters, and then my top is equal to A plus H tan theta. So I get that my top is actually equal, when I work all this out, 2.7 meters. The next example that I've done out, I'm told the net of a 3D figure is shown in the diagram. Both triangles are isosceles and congruent. Calculate the length of the side x centimeters, draw the sketch of the 3D figure and name it, calculate its volume, and design a trapezium prism the same volume. Okay, so this is my net that I've been given, and I'm basically looking to find out my x. Okay, right, so what I have here, okay, so basically what I have is I actually have a triangle made out. Okay, so my full length of my triangle is 3 centimeters, so I'm going to split it in two. Okay, and I know that my height of one of my triangles is 2 centimeters, and I'm looking for my x here. Okay, right, so I'm after dividing this in two because I want to be able to use Pythagoras' theorem to solve for my x. So I get a squared plus b squared is equal to c squared. Okay, so I drew out a diagram here again. So I have 2 to be squared plus 1.5 to be squared is equal to x squared. So I have 4 plus 2.25 is equal to x squared. X squared is equal to 6.25. X is equal to square root of that. So I get that x is equal to 2.5 centimeters. I was asked to draw out the shape that it made with the net. It makes triangular prism. Then I'm asked to get the volume of it. Okay, so the volume is the area of my cross section multiplied by my length. Okay, so my area of my cross section, in this case my cross section is a triangle, so it's the area of triangle multiplied by my length. So my area of my triangle is half the base by the perpendicular height, so it's half, my base was 3, my perpendicular height was 2, multiplied by my length is 8. Okay, so I get that the volume of this particular shape is 24 centimeters cubed. Part 4 then, I was asked to draw another trapezium that would work for these figures. So I let the height equal to 3 centimeters, I let the width equal to 2 centimeters, and the area of trapezium is 24 over 2 is equal to 12. Okay, so I get the sum of the parallel sides is a plus b. So I go a plus b over 2 multiplied by 3 is equal to 12. So I go a plus b is equal to 8, so I get a is equal to 5 and b is equal to 3. So in this particular example, my base is 3 centimeters, my top is 5 centimeters, and my height is 3 centimeters, and the width is 2 centimeters.